Okay, welcome back. We're working on our midterm review for questions 25 through 30. Okay, looking at this question, okay, what must be added to 2x squared minus 5x minus 12 in order to get 7x squared minus x minus 18? So really, even though it says added here, it's saying what do you need to add to this right here to get this? Which is kind of like that find the missing side question, okay? And so what we'll do is we'll take our answer, which is this one, okay? 7x squared minus x minus 18, and we'll subtract this one. So we will take this question this polynomial right here and subtract it. So we're going to subtract, okay? And I'll write it in green. 2x squared minus 5x minus 12. Okay? And the key here is to remember that when you subtract something, really you just change all the signs. So we'll do it as we go. What's 7x squared minus 2x squared? Well, that's 5x squared. We have a negative x minus a negative 5, which is really minus a minus becomes a plus. Okay? They're different signs, so we'll subtract. This is an understood 1. Okay? 5 minus 1 is positive 4. And then we bring down the x. Okay? Then we have a negative 18 minus a negative 12. Minus a minus makes a positive. Okay? These now have different signs, so we'll subtract with 18 minus 12. That's 6. And then 18 was bigger, it's negative. And so this becomes our answer. Okay? Question 26. We look, we have a parentheses, and we have an exponent on the outside. So we look, there's no subtraction or addition in here. This is a negative exponent, okay, not a subtraction sign. And since there's no addition or subtraction, this becomes an exponent distribution question. So we're going to distribute to the 3 items that are in here. Okay, and remember the 16 has an understood 1 there. So then you get 16 to the negative 1/2 power. You get x to the negative 6 times negative 1/2. And then you get y to the 2 times negative 1/2. Okay, so then when we do this, if you remember in previous questions, anything to the 1/2 power is kind of like saying the square root, okay? And then we also have a negative exponent. So when we have a negative exponent, we need to think about a lot of different things, okay? First, there's a fraction bar, okay? That's understood, and normally we'd have a 1 here. And anything that gets a negative would go to the bottom, okay? Since this is already kind of multiplied together, we know that it's negative. So this whole term right here will actually go to the bottom and become positive. Okay? So I'm going to write a new fraction bar. And this is going to be 16 to the 1/2 power. Okay? So now let's look at the x. We have x to the negative 6 times negative 1/2. Or what's half of 6? It's 3. And then a negative and a negative make a positive. Okay, the x becomes x to the 3rd, okay, and it's positive, so it'll say x to the 3rd on top. Okay, remember, negative 2 times a negative and a negative make a positive, and 6 and half of 6 is 3. So a positive 3, and the positive will stay on the bottom, on the top. Jeez. 2 times negative 1/2. Well, a positive times a negative is a negative. Okay, so we know we're going to have a negative answer. And then what's half of 2? It's 1. So you get really, it's like y to the negative 1. And a negative means we would write it on the bottom. So it becomes y to the 1 on bottom. Okay, and then we don't need the 1. Okay, if you left it there, I wouldn't take any points off. But you want to try to write it as simple as possible. And then 16 to the 1/2 power, if you had your calculator, you could type it in there, or it really means the square root of 16. and the square root of 16 is 4. So your final answer would be x to the third over 4y. Question 27. If you look, we have a big parentheses, and there's a monomial on the outside. This is a monomial times a 4-term polynomial. Okay, 1, 2, 3, 4. We'll distribute. Okay, 3 times 7 is 21. A squared times a to the 6th. When you multiply like bases or variables, you'll add their exponents. So 2 plus 6 is 8. Okay? And then I'll change the colors to see it. So then you have 3 times positive 5 is positive 15. And then a squared times a to the 5th. Multiplying variables, you add their exponents, so you get a to the 7th. Okay, let's go green. 3 times negative 8 is negative 24. And then a squared times a to the 4th. Variables, we add exponents, and you get a to the 6th. And then we do 3a times positive 1, or excuse me, 3 times positive 1 is positive 3. And then we have 2 a's here, and we don't have any to multiply it to, but it still comes down. This is going to be where most people make the mistake. They forget to bring down that a squared. So please don't forget to do that. If it's on the outside, it's going to be there no matter what. Okay? And then you add whatever you had on the inside to it. So since there was nothing else to add to the a squared, it's still a squared. Okay? Looking at question 28, we have p minus 5 in parentheses all squared. Okay? This is one of those ones where you want to rewrite it as p minus 5 times p minus 5. Okay? And so this we would use the box method for, or you could use the distributive method. Okay? And we're going to do the box method here. Okay? P times p is p squared. P times negative 5 is negative 5p. Negative 5 times p is negative 5p. And negative 5 times negative 5 is positive 25. Okay? We look for our like term peanut in our box. Okay? Negative 5 plus a negative 5, or they're same signs, so we add them, and you get negative 10p. And then we want to bring down our corners, the p squared and the plus 25, and this becomes our final answer. And those of you who are very good at doing your multiplication skills, this becomes p squared, negative 5 squared, which is 25, and then you go 2 times negative 5 times p, which is negative 10p. That's the shortcut method if you were trying to learn one. Okay? If not, if that confuses you, stick to the box method. That's okay. Let's look at question 29. Okay? So, this is like the exponent division sign. Okay? And when you do numbers, you just do the third root of 27. So look at this big number here. Okay, that's a coefficient, if you want to call it that, or it's just a regular number. You would do the third root of 27, or ask yourself, what do you have to multiply together 3 times to get 27? And the answer is 3, because 3 times 3 times 3 is 27. Okay? And then you bring down the times 3. Okay? So then we know 3 is the right answer, so this part breaks down into 3. Okay? Now I told you a second ago that this is kind of like the division sign for exponents. Okay, so we'll take this 3 and divide the exponent 12 by 3. Okay, and so you get a to the 12 over 3, and 12 divided by 3 is 4, so you get 3a to the 4th. Okay. Question 30. Okay, given the trapezoid below, express the area in terms of x. Okay, this is going to be a question that you actually need to know the formula, and we'll write it. Now, if we give you this question on the test, we're going to give you the formula. The area of a trapezoid is 1/2 the height times base 1 plus base 2. Okay, this is your base 1, this is your height, and this is your base 2. Okay, so if we go through and we plug in what our stuff is, we get area equals 1/2, and then our height is x plus 1, and then in parentheses we have base 1, which is x minus 1, plus our base 2, which is x plus 5. Okay? So now, normally we'd have something here that you could easily divide by 2, but in this case we don't. So we need to go through and figure out what's inside this parentheses before we start multiplying by 1/2 or anything like that. So inside here we have like terms. We have x plus x, which is 2x, and then we have minus 1 plus 5. Negative 1 plus 5, they're different signs, so we subtract. 5 minus 1 is 4, and 5 is bigger, so it's positive 4. Okay? Now, that you want to keep in parentheses. The x plus 1 will come down because we haven't used it yet, so will the 1/2 equals the a. Okay? So now we look, and obviously this one's not divisible by 2 or able to take half of because we would have done it in the first place. However, if you look at this parentheses over here, are these numbers easily taken half of, 2 and 4? Absolutely. So what we can do is we can use this half with these numbers here. Okay? Now you say, well, it's not next to that. It's okay. Multiplication has what we call the commutative property, where we're able to move stuff around and multiply what we would like to. For example, if we had 2 times 17 times 5. 2 times 17, some of y'all might not know that right off your head, but you do know what 2 times 5 is, which is 10. So you could go ahead and multiply 2 and 5 together and get 10 times 17, and 10 times 17 should be easy to get 170. Whereas if you'd have done it the other way, it might have been harder, because you'd had to do 34 times 5, and I don't even know what 34 times 5 is off the top of my head. I'd have to multiply it out. Okay? So sometimes it helps you to be able to move stuff around, and so in this case, you can move stuff around, such as putting this 1/2 next to the 2x. So we can take 1/2 and do half of 2x, which is 1x, and half of 4 is positive 2. Okay? And then we bring down the x plus the 1 that we used, or we didn't use yet. And then now we have two things that we can multiply together. This is a binomial times a binomial, so we use the box method. I'm going to write the x and the plus 1 here, and then I'll write the x and the plus 2 here. Draw our box. Okay. And then we got x times x is x squared. X times positive 1 is positive 1x, or just x. And then 2 times x is positive 2x. And then positive 2 times positive 1 is positive 2. Make sure that when you're multiplying these, you multiply this last one. You don't go 2 plus 1 is 3, because that's not multiplying, that's addition. You multiply to get in. Then we have our like term peanut. Okay? And so you have 2x plus an x, that's 3 x's, okay? And then we bring our corners in, x squared, and that's a positive 3x. And then we have positive 2 over here. And so you see that this becomes our answer. Thank you for watching questions, what was that, 25 to 30.